What's going on, you guys? So today we're going to work on merging two sorted lists. And so the idea behind that is we're going to take two lists and we want to sort them in ascending order, so least to greatest. Well, yeah. Um, yeah. So we get two sorted lists, so we know that they're in ascending. Each is in ascending order. So the result should also be in ascending order when we sort it. Okay, so how are we going to do that? Let's take an example and let's work it through. Okay. All right, so let's think about this. So we're going to compare 1 and 1. We're going to say, all right, we're going to choose 1, and that'll be what we take. And then we want to compare. Now we have left 2 and 4 and all of L2. So we're going to compare 2 with 1, or okay, we're going to take 1. So now we're going to compare again. We have this shortened list 2 and 4 and 3 and 4. Okay, okay, so that's the output. Okay, so we got so all right, we start off with nothing. So we've got L1 and L2. We're going to compare 1 and 1. We're going to take 1 from, let's say L2. We'll take it from. Put that in here. Okay, so now we're going to compare 1 with 3. Okay, we're going to take 1. Put that in there. All right, and now we're going to compare 2 and 3. So we're going to take 2. And now we're going to compare 4 and 3. We're going to take 3. We're going to compare 4 and 4. We'll take 4. Now we're going to compare 4 and nothing, and we'll just take 4. And so that's how we're gonna try and recreate that with code. So how can we do that? Okay, and let's think about space and time complexity. So time complexity is going to take n plus m time, where n is the length of L1 and m is the length of L2, combined length of L1 plus L2. And space complexity, so this depends on if we do a recursive function or an iterative function. If we do iterative, it's going to be constant space. If we do recursive, it's going to be O of n plus m space. And we're going to do a recursive function because I think it's a little bit easier to understand what's going on. So what's the base thing that's happening here? We're doing this comparison. We're saying if L1 dot val is less than L2 dot val, what do we want to do? We want to take L1's current value. Okay. So L1 is going to be, like, the head of L1 will be what we're going to return in the end. And then we're going to figure out how do all the other values come after L1, right? Because L1 is just a node. So L1 is pointing to this, but it has a next and a next. So we're going to figure out what L1.next is, and then we're going to return L1. Because once we figure out what is coming after L1, that will be the sorted value. And so how do we do it? How do we do it here? When we figured out what value we're taking, then we're going to redo this comparison with a truncated value, right? So we we redid this with 2, 4, and 1, 3, 4. So how can we do that here? We can say merge two lists L1.next, right? And so that's going to correspond to 2, 4 and L2. And so that's going to go and that's going to figure out what is coming after this value. And once you figure out everything that comes after this value, return this value, right? And it will have all the correct next values. Okay? And else, so otherwise, we're going to do the same thing for L2. Like for example, if we had if this was the input, this would go 1, 2, 2, 3, 4, 4. Okay, so if this was the input here, then we would hit the else block in our code, right? Because 2 is great. Oh, hold on. No, this would have to be like 0. Okay, wait. No, that was right. Oh man, sorry guys. Okay, so we hit the else block when L2's value is less. So in this case, 2 and 1. Okay, we're going to choose 1. So that's okay. Return. So return L2, which is 1, and along the way, figure out all the values that come next by recalling this function recursively. And so the reason this takes O of n plus m space is each time we recall merge two lists, that takes up required space on what they call a call stack. All right, let's see if that works. All right, what's the error here? Only safe calls. Okay, so in Kotlin, we need to make sure that, so these could be null. So we need to say, all right, this could be null. And that's what we're noting here with this question mark is, hey, this could be null here. We're gonna have to do this everywhere. Okay, let's try that again. Operator call corresponds to a dot qualified call, which is not allowed on a nullable receiver. Interesting. Oh, right. So, all right. I made a mistake here. So what happens if L1 is null or L2 is null? We need to handle that case, right? Because at the end here, we had 4 and nothing. So we need to handle when one of the lists is null. My mistake. Okay. Okay. Let's think about this. So if L1 is null, return L2, right? So in this case, L2 was null. So we're going to turn L1. And now we know, we have these null checks. We know these will never be null. So we shouldn't need to give it the question mark indicator because we know that they're not null after these two checks. But we'll see, we might have to. Okay, there you go, guys. So that's a recursive answer to merging two sorted lists. You could also do this iteratively, and so that would just be O of 1 space with the same time complexity. But I thought the recursive function is a little bit prettier. It takes a little bit less code, and it's kind of clearer to see what's going on. But go ahead and give the iterative one a shot as well. All right, you guys. Till next time.